So we're on page 37, and we are going to do two examples on that. So if we look at example 1, we're asked to graph the linear inequality 2x plus 3y greater than 6. So the first thing we have to do is get the boundary line. That is just the line that relates 2x plus 3y equal to 6 right over here. We're going to use that because the inequality will be true on one side of the boundary line and not true on the other side. But first we have to establish the line itself before we establish which side of the line we're going to shade on. So we get 2x plus 3y equals 6. We just do that for reasons of obtaining the intercepts. So we set x equal to 0 in this equation. If x is 0, 3y equals 6, and y equals 2. So x is 0, y is 2. When x is 0, y is 2. So we know one of the points, one of the ordered pairs that describes the boundary line is 0, 2. That's this point over here. Now we set y equal to 0 back in this equation. If y is 0, then 2x equals 6 and x equals 3. So for this case, we get 3, 0. When y is 0, x is 3. So that's the x-intercept. So we have the y-intercept and the x-intercept. The x-intercept, the y-intercept is 0, 2. The x-intercept is 3, 0. We draw a line connecting those 2 points. And the line will be dotted because there's no equal sign. So the line is dotted because there's no equal sign. If there were an equal sign here, greater than or equal to, then the line would be continuous. Now, the next part of the problem is to check what side of this line is going to be shaded and going to give us the inequality 2x plus 3y is greater than 6. So you can see here that 0, 0 is very clearly on one side of the line, and it's always easier to work with 0, 0. So because the arithmetic involving it makes it much simpler. So we're going to put 0, 0 into the equation 2x plus 3y greater than 6 and ask ourselves, is that true if we use 0, 0? So 2x is 2 times 0 plus 3y is 3 times 0 greater than 6. Is 0 greater than 6? No, that's false. 0 is less than 6. So we can't shade with the line. The shaded part of the graph will not contain 0, 0. So we know, therefore, the other side of the line must be shaded because the 0, 0 doesn't fall within that. Now, when you're testing, you always substitute the test point into the original equation 2x plus, in this case, 2x plus 3y greater than 6. Now, we can check our answer by choosing another point that we know lies within the shaded region now, just to check it out. For example, here, 4, 0 would be right about here. X is 4. Y is 0. We know that should work. So we're going to put 4, 0 back into the original equation 2x plus 3y greater than 6. So x is 4 and y is 0. We ask, is 2 times 4 plus 3 times 0 greater than 6? Well, 2 times 4 is 8. Plus 3 times 0 is 0. So is 8 greater than 6? Yes. So 4, 0 falls in the shaded region. This supports the idea that we shaded on this side of the line. So any number that's on this side of the line should work. Now let's go to the second example on page 37, which asks us to graph the linear inequality y is less than or equal to 2x. First thing we always do is find the boundary line for the equation with just the equal sign in it. So in this case, when we set x equal to 0, y is 0. 2 times 0 is 0, so when x is 0, y is 0. Also, when we set y equal to 0, that means 2x equals 0, so x equals 0. So we only have 1 point. We know 0, 0. So what we do is just choose a simple value for x here. For example, we choose x equal to 1. 2 times 1 is 2, so y is 2, and that gives us a second ordered pair. Because we can't get a line from just 1 point. We need 2 points to connect to get the boundary line. So we've got the point 0, 0, and we've got the point 1, 2 here. We connect these, and this gives us the boundary line. Now, the line is solid because there's an equal sign in there. Right there, so we make that solid. If there's no equal sign, the line has to be dotted. And now we're going to test 1, 0 as a test point, because we know 1, 0 lies on clearly on one side of the line. X is 1 and y is 0. It lies along the x-axis. We can see that it clearly lies on one side of the boundary line, although we don't know that it's shaded yet. So we put 1, 0 into the original equation, which means that y is 0. 0 is less than 2 times 1. Is 0 less than or equal to, 2 times 1? And the answer is yes, 0 is less than 2. So that's okay. 0 is less than true, which means that we shade on the side of the line that contains 1, 0. Not on this side, but on this side, because using the test point 1, 0 works. So we shade the region containing 1, 0. Now let's choose another test point that we know lies outside the region just to be sure. For example, we chose -2, 0, which is over here. We know that that test point shouldn't work. But let's check it out and see if that's true. So we put x equal to -2, and we put y equal to 0, and ask ourselves, is that true? Is 0 less than or equal to 2 times -2, because we put 2x and x is -2. So we're asking ourselves, is 0 less than or equal to -4? No, 0 is greater than -4. It's not less than, nor is it equal to -4. So the point -2, 0 cannot fall within the shaded region.